the previous video, we learned blasting and use electric blasting circuit to blast the rock. And we review Ohm law and how to determine resistance for parallel series circuit. And have a reference for a different table to determine the resistance, minimum current, etc. Then we applied this video, we apply that concept in problem 3 and analyze the cap circuit shown in the figure below, that is the circuit, to determine the circuit resistance, the minimum power source current, and the voltage necessary to fire the blast. Caps are equipped with 30 feet leg wires, assume normal firing conditions. So with that, we go back to review what are the steps in blasting circuit analysis. We have 6 steps in here. The first, determine the resistance of the cap circuit. Then determine the resistance of the bus wire and connecting wires. And then determine the resistance of the firing line. Then add up the first 3. We go to step 4, compute the total circuit resistance. And we use table 6.5 to determine the minimum total current requirement. And the last one, we solve for the required power voltage using Ohm law. If we know the power voltage, then we solve for the current and compare with the value in step 5, which we go back to table 6.5 again. So that is that. Now let's go to first start with the resistance of the cap circuit. How to determine that here. And that go to continue here. As you can see, to determine the cap circuit, we go to tables 6.6. Then we have the resistance for the cap circuit. Let's go back to table 6.6. And that is 30 leg wire. Then we have 2.2 nominal resistance, ohm, in ohm 2.2. So from that we can have R equal to equal to 2.2 ohm. And from that, and this is for per cap. This is per cap. How to determine the resistance for a cap circuit? That's the equation here. RC equal to number of caps per series times the resistance per cap that we just determined. Divide by the number of parallel branches. Let's see the circuit. How many series we have? We have each series we have 3 caps. And then how many parallel branch we have? We have 3 branches. So that is applied in that equation. Number of cap per series times the resistance per cap divided by the number of parallel branches. So that one here, we can use that equation to determine the RC, resistance of cap circuit, and that equal to number of cap series. So we have 3 cap per series time resistance per cap 2.2 divided by the number of parallel branches, and in this case you see 3 branches there, so divide by 3. So from that we have the resistance of the cap circuit equal to 2.2 ohm. And then we want to determine the resistance of bus wire. That is the step number 2. Step number 2. So that to determine that, we need to find out the effective length of the bus wire. And in this case, they give us a number 18. As you can see given in the problem, that in number 18 in here for the bus wire. And then we can go to table 6-7. Go to table 6-7, so we can have the resistance. But before we make the effective plan, so let's go here for bus Y. So it have equal to, and you can see from the geometry here, we have AE given, AE equal to 20 feet. Then we each space ES, so we have 4S of that, the top and the bottom, and then we plus CF, that is the bus Y go there. So it equal to AE plus 4S, because you have there top 2 S's, and then the bottom 2 S's plus CF. And the problem give us AF equal to CF 20 feet, so you have 20 S equal to 10 feet, so you have 4 times 10 plus CF 20, so we have 80 feet. And then we go to table 6-7. Go to 6-7. And again, keep in mind that in number 18 for years. So go back to the April 6-7. And in this case, the number 18. So you have 6.38 ohm per 1,000 feet. Keep that in mind. The unit is ohms per 1,000 feet. From that one, we can go back here. It will be table here for number 8. Number 18, we have 6.38 ohm per 1,000 feet. And here we only have 80 feet, so we can determine the resistance of the bus wire, 80 feet times 638. We have to divide by 1,000 feet, so we will get 0.51 ohm. And then do the similar, we can be able to determine the firing line, and that is number 12, firing line number 12. So we can also have the firing line and that is number 12. And number 12, we also go to table 6-7. We can find out what is the number for that sample. Number 12, we have 1.59 ohms per 1,000 feet. So that one here, we can have there is 1.59 ohm per 1,000 feet. With that, we can be able to determine the step 3, which is the resistance for the firing line. And that firing line, and you can see the 1,000 for one way and go back and forth from the power source to A and from C to back to the power source. So we have that equal to 2 times 1,000 feet times 1.59 divided by 1,000 feet. So from that we get 3.118 ohm. And that we move to step 3. We have R total, the total resistance. Step 4, total resistance. And that equal to all the first three, 2.2 plus 0.51 plus 3.18. So we get 5.89 ohm. And then we have the last two steps. We determine the minimum current requirement. So that we'll have go to table 6.5 to determine the minimum current in ampere per caps, per 1 caps. And this one is in the normal condition, normal firing condition. And power source is given. So let's go back to that figure, that table 6 here. And with the DC direct circuit, the direct current, we have, and in our circuit it parallel series combined, not series, not parallel and series, 3 parallel branches, and each series have 3 caps. So it will be 1.5, the unit is ampere per series. You see that 1.5 ampere per series. That's the minimum current have to maintain. So that one here is equal to 1.5 ampere per series. So from that we can determine the requirement current in the file line. Then we can have the required current in file line. And as you can see, it's series. We have 1.5 ampere minimum, and we have, as you can see now, parallel we have 3 branches. So the file line it had to distribute to each series, and we have 3 series, the 3 branches of that. Then we have to time 3. Just think about the water. You have a river and go to 3 branches. So the volume, the flow in the main river go to 3 branches of the river. The total flow for each river, add them up, each small river have to be equal to the flow of the main river. So with that one, we can have that is equal to 1.5 ampere times 3. In this case, 3 branches, parallel branches. And that we have 4.5 ampere. And that is the first one. And the last step is we determine the voltage necessary. So it will be apply the Ohm's law, minimum voltage, and that the Ohm's law is equal to current times the resistance, as you can see there. So current in this case 4.5 time resistance, total resistance. That's why we have to find out 5.89 ohms. So we will get 26.5 volt. And that the answer. The question also asks what is the minimum power source current. So that is the answer as well. The answer. And the circuit resistance. So that also the answer to need to find out. So that finished the problem 3.